So I'm very pleased to introduce our first keynote speaker, one who is very well known by our EANET community, that is Dr. Hajime Akimoto, who is the guest scientist at the National Institute for Environmental Studies, Japan. And he is also the former Director General of the Asia Center for Air Pollution Research. So Dr. Akimoto will share about the progress of improvement, challenges, and the way forward on air pollution management in East Asia. And so with great pleasure, let's hear from Dr. Akimoto. Dr. Akimoto, over to you.
Thank you very much for the nice introduction. Good afternoon, everybody. And it's my great honor to have a chance to give a keynote speech for this EANET 20 years anniversary. Since the time is limited, let's start the first slide, please. The next one. Okay. We'll start this slide showing the historical emissions of SO2 and NOx in East Asia, comparing with Europe and North America. The red line is for East Asia, and the green and blue line is for Europe and North America, respectively. As you can see, the crossover of the SO2 and NOx emissions in East Asia exceeding Europe and North America happened in early 1990s and middle of 1990s, respectively. And during the EANET period, the last 20 years, the emissions of NOx, SO2 and NOx in East Asia is predominant in the world. So, okay, the next one, please. Okay, this picture shows the emissions of SO2 and NOx versus GDP for the EANET participating countries during 1990 to 2015. The red and the other bright color lines are for SO2, and blue and other dark color lines are for NOx. And the leftmost dot for each country is 1990, and each dot shows the 5-year interval of increasing of the GDP and emissions. So that's interesting to see. At the beginning of EANET, or before the beginning of the EANET in 1990s, the Japan's GDP to the right, and many of our Southeast Asian countries' GDP are different, or the gaps are more than 2 orders of magnitude. But in the last 20 years, the Japan's GDP didn't increase much. But on the other hand, the most of other countries' GDP increased more than order of magnitude. So at the beginning, the difference in GDP in Japan and many other countries are nearly sometimes 2 orders of magnitude, but now it's within one order of magnitude. And also the Japan GDP didn't increase, but the NOx and SO2 emissions have been decreased. And as you can see in the top of the figure, the China's GDP increased more than an order of magnitude during this period. And the SO2 emission is already started to decrease, as we saw before. So we can see the very much heterogeneity of economic and also the geographical emissions of the SO2 NOx emissions in East Asia as compared to the Europe or North America. Okay, and the next, please. Okay, this is a kind of summary of what EANET has established as a or it says an example of basic achievement of EANET. This picture shows the concentration of non-sea salt sulfate and nitrate, and also the pH of precipitations as a function of annual precipitation amount. And all the colored dots are for East Asian countries monitoring data, and black crosses are for EMEP for Europe, and what to say in NADP, sorry, NADP in United States. So we can see, and also these solid lines are the annual wet deposition amounts of each species. So you can see the East Asian mean concentrations and also the deposition amounts much exceeding Europe and North America in many of the parts. That's what EANET has established. And then what was caused by these acidification in East Asia? So the acidification in East Asia is much stronger than the other part of the world. But what caused what do the effect or impact looks like? The next one, please. So we made a review of 30 years of deposition of development of science policy related to acid deposition in East Asia, reviewing the journal papers. And what we found is like this. First, limited acidifying trends of inland water and forest stores have been documented. However, decline of fish populations and other aquatic biota due to the acidification has not been reported. Forest decline or visible forest tree damages have been reported in China, Japan, and the Republic of Korea. The causes has been speculated to be due to acid fog, air pollutants such as NO2, SO2, hydrogen fluoride, or ozone, and pests or insects and their combined effects. The cause due to acid deposition-induced soil acidification has not been identified. These are the very short summary of the acidification in East Asia in the last 30 years. Okay, next please. So after recognizing these facts, our scientific guideline for future direction of EANET is something like this. Fortunately, acid deposition per se has not caused serious damage on neither to aquatic nor terrestrial ecosystems in East Asia. However, nitrogen saturation of forest soil due to excess deposition of nitrogen, nitrate, and ammonium ions is now a large concern for ecosystem impacts. Second, meanwhile, air quality issues caused by high levels of PM2.5 and ozone have become quite serious in many countries in this region, as alerted by WHO and Global Environmental Outlook published by UNEP. And third, climate change has become an issue of increasing concern in relation to science and policy. It is now recognized that co-controlling the CO2 and SLCPs are short-lived climate pollutants, which I will mention later again, is mandatory for controlling global warming in near and long-term future. Economical co-benefits of simultaneous reduction of air pollutants and climate pollutants are well recognized. Next, please. So the first issue of nitrogen saturation means disturbance of nitrogen nitrogen cycle in forest ecosystems due to excess nitrogen inputs. So the reduction of nitrate and ammonium deposition by emission control NOx and ammonia are necessary, I think. And these two pictures shows the left-hand side is the emission trends of NOx from 1980 to the present by several emission inventories. As you can see, after 2010, the NOx emissions has been decreasing in East Asia, mainly due to the reduction of emissions in China, Japan, and Republic of Korea. However, for ammonia, the right-hand side, the several emission inventories of ammonia shows that no indication of decrease of emissions can be seen. So in the next 10 years, the mitigation of ammonia emission should be a concern for policymakers. Okay, next one, please. Okay. So the priority species to be monitored based on scientific guideline is from the first issue of the nitrogen saturation is NOx and ammonia are the key issues, as we saw before. And for air pollution issue, as you know, the PM2.5 and ozone and their precursors, NOx, SO2, and NMVOC, those should be of the key concern. And air quality climate issue, like SLCPs, as I mentioned, SLCP is major SLCPs are methane and ozone and black carbon. So these two pictures show the methane and ozone's concentration. The brown curve is for global mean concentration, and the blue one is the so-called radiative forcing, which is index of global warming. So those the concentrations and the global warming potential has been increasing from 1900 to the present, like this, for both ozone and methane and ozone. So we are expected to decrease those concentrations toward the 1960 or 1970 level, as shown by the red arrow in these pictures. So the SLCPs are methane, ozone, and black carbon, and the precursors, non-methane, NOx, and NMVOC, etc. like this. And I'm pleased to see that the opening talk of Mr. Azuma mentioned that the EANET, the monitoring species are expanded, including the non-methane VOC or ammonia, and CH4 has not been included now, but in future may be concerned. Okay, the next one, please. This is my last message, is Epistemic Community of Science and Policy Interface in East Asia. What is epistemic community? An epistemic community is defined as a network of professionals with recognized expertise and authority to policy-relevant scientific knowledges in a particular research field. It's a definition of the epistemic community. Scientific knowledge based on trust and consensus among the members of the epistemic community is considered as a critical element for successful environmental cooperation among countries. The time had not yet come for such a community to emerge in Asia 20 years ago when EANET started. Many countries had difficulty in dispatching experts with professional knowledge to for example, to the SAC meeting. But the time has been changing now. Epistemic communities in atmospheric environment field in Asia has now been forming, for example, through the National Intercomparison Study in Asia, a model intercomparison study in Asia, so-called the Mixed Asia Project, and Science Panel of the Asia Pacific Clean Air Partnership, APCAP, under UNEP ROP. And I think the EANET SEC is now expected to be more close to the kernel of the epistemic community. This is my last message. Thank you. To the next one, please. Yes, so I expect future successful development of EANET for the governance of atmospheric environment in East Asia. Thank you very much for your attention.